Welcome everyone, Math 105, this is Lesson 14, the International System of Units, otherwise known as the metric system. Please start with a warm-up. See if you can do these without using a calculator. Just recall that multiplying or dividing by powers of 10 involves nothing more than moving the decimal point around. Just a reminder, in your turns, make sure you pause the video and then come on back when you're done. Alright, multiplying by 10, we're going to make the number bigger, since we're multiplying by a number greater than 1. So that's going to move the decimal to the right. There's 1 0, so move it one place to the right. 86.72. Next one, 2 zeros, two places to the right. 867.2. And now I've got 10 to the third. That's just like writing a 1 with 3 zeros, so 1,000. So move it three places to the right. 8672. Alright, now we're going in the other direction. Dividing by 10, we're going to move the decimal point starting just to the right of the 2, one place to the left, one for each zero. So that's 867.2. And divided by 10 squared, that's 100, so we'll move it 2 to the left to get 86.72. And finally, divided by 1,000, we'll move it 3 to the left to get 8.672. Now in the metric system, they start with a bunch of base units, which are all derived from physical measurements. And you can see the table there. Got length, mass, time, temperature, quantity of matter, electric current, and luminous intensity. And this table actually uses some of the British spelling, so sometimes they swap the R and the E. So meter is M-E-T-E-R, not R-E. And that basic unit of the meter is derived from a physical measurement. The meter is defined to be the distance that light travels in 1 over a very large number of a second. And then we have a table with the derived units. And derived units are those that are made up of the basic units. So here's an example of how we can take a basic unit and turn it into something else. So we'll take a basic unit of length, which is a meter. So we got here 1 meter. And then if we want to make an area out of it, we'll have 1 meter this way. And now I've got an area. And this is a meter squared, or a meter times a meter. You can see there's quite a few units that are done like that, like density, kilogram per meter squared. So now I've got an area of volume and of mass. And then down below that, you can see we've got other derived units, like the liter, which is based on a square meter or a square centimeter. And then the milliliter, which is a square centimeter. So they all relate back to those basic units. And what we're going to learn today is about the prefixes, and that's how we adjust the base units, and then converting between the various types of units. So we've got here a table of prefixes, and these will be put before the base units. And the base units are, for the basic quantities, are kilogram for mass, we've got a liter for volume, and we've got a meter for distance. And those are the base units we're going to be modifying. And there are others. You can make a base unit out of anything. As we'll see, there's a lot of computer-based base units, like a byte is used as a base unit. And then we modify those by attaching a prefix to them. So here are the prefixes which change the value of the base unit. So if we wanted something larger than a base unit of, let's say, a meter, we could attach kilo to it and create the kilometer. And the multiplier is 10 to the third, so a kilometer is 10 to the third meters. That's basically how that table works. So if we look at the first, notice that in the table here we've got some negative exponents down here for those smaller units. And so we should talk about what a negative exponent is. So a negative exponent is basically the same as taking this expression and moving it to the denominator. So 10 to the second power with a positive exponent is the same as 10 to the negative 2 if the negative 2 is in the numerator and the 10 squared is in the denominator. So basically the idea is if you take some expression with an exponent and move it across the divisor line, you change the sign on the exponent. So and anything can be written over 1, so as we take this in the denominator and move it to the numerator, the exponent changes sign. Alright, so this 10 to the negative 2 would end up being 1 over 100. So that's equal to. All right, go ahead and do this with your turn number 1. Write a fraction for 10 to the negative 4th power. All right, so if you want to make it positive, move it to the denominator. The exponent becomes positive. And then 10 to the 4th is 10,000. So 1 over 10,000. All right, now we're going to refer back to the table, figure out how many meters there are in a hectometer. All right, so base unit is here, hecto is here, and the exponential expression here tells us how many base units there are in something with a hecto prefix. So when we're talking about meters, that would be 10 to the 2nd power meters in a hectometer. So just look up the power in the table and that'll tell you exactly how many base units there are in any one of these units built with a prefix. Your turn number 2, how many meters are there in a megameter? I will find the mega prefix that has exponential part of 10 to the 6th power. So that means there are 10 to the 6th meters in a megameter. All right, now we're going to be converting metric units. And there are 2 different methods you can use. You got the counting method or the formula method. So I'm going to show you the formula, and we'll show how it relates to the counting method. So to convert between units, we need what's known as a conversion factor. And that is a number that you take the original units and multiply it by to get the new units. And so that conversion factor is going to be, we're always dealing with powers of 10 with the metric system. And so we'll take a 10 and we're going to raise it to a certain power. So we're going to take the power of the original unit minus the power of the new unit. And we'll subtract those and we'll get 10 to some power. Just like we have over here. Now the counting method basically does this subtraction for us. So if we look up our 2 units in the table, then we're going to add the spaces between the original and the new unit. So we're starting with the new unit and we're going to count up to the original unit. And we're going to count by 1s for all the units that are close to the base unit. So everywhere between milli and kilo. All right, so this is where counting by ones. All the way down to here. And that is because with these units, they all change by power of 1. And up here, we're going to count by 3s because those are all changing by powers by 3s. And all the way down here. And then the result of counting becomes the power of 10, just like the subtraction becomes the power on that 10. So let's see how this works. Let's change, in example 3, 8 centimeters to millimeters. All right, so we're going to go over here to the table, find centi and milli. So we're starting at centi, going down the milli, and if we go down in the table, if the table's oriented like this, with the larger stuff at the top, smaller stuff at the bottom, if we go down the table, that is a positive 1 move. If we go down is positive, up is negative. May seem backwards, but it's just how it is. All right, so that means the power on 10 is going to be 1. So we take the original number 8 times 10 to the first power, and that gives us 80. So 8 centimeters is equal to 80 millimeters. All right, try this out with your turn, number 3, 9 liters to centiliters. And when you write the liters, use a capital L, because small l looks like a 1, leads to a lot of confusion. All right, so liters is the base unit. That means we're going to start right here at the base. Whenever we see liters, meters, or grams. And I believe I messed up and said the base unit was a kilogram later. That's a gram. Okay, so we're going to start here, and we're going to count down to centi. So that's 2 moves down. We're counting by ones here. So that makes the exponent 2. So we'll take 9 multiplied by 10 to the second power, which is 100, and that gives us 900 centiliters. So 9 liters is equal to 900 centiliters. Our next example, 15 decigrams to hectograms. All right, so we are at deci. We're going to need to get up to hecto. Now make sure when you count the base unit. This is a step. And these are all worth 1, so 1, 2, 3 steps up. Now since we're counting up, the exponent will be negative. So that means we're going to do 15 times 10 to the negative 3 power. All right, 3 moves in up direction. That gives us negative 3 on the power. Multiply that out. Multiplying by something to an exponent, and this tells us how many places to move the decimal. All right, so that means we're going to go 1, 2, 3 to left, 0.015 hectograms. Your turn number 4, change 180 millimeters to decimeters. All right, millimeters is here, deci's here. Don't confuse deci with deca. They're fairly close to each other. All right, we're going to move up 2. It's in the up direction, so that is a negative exponent. So we'll do 180 times 10 to the negative 2 power. And now if we do the subtraction method, what we're doing is subtracting exponents in the same order, all right? Negative 3 minus negative 1. All right, so we get that negative 2 the same way. So whether you want to do subtraction or counting, that's up to you. I was going to take a decimal to the right of the 0, move a 2 to the left, get 1.8. 1.8 decimeters. All right, next up, we're going to do 847 gigagrams to exagram. We're going to find giga, going up to exa. Now we're counting by 3s because we're outside the first 3. So from giga, we're going 3, 6, 9. It is in the up direction, so that is negative. So that gives us 847 times 10 to the negative 9. So another way of doing that is subtracting the exponents. We'd do 9 minus 18 gives us the negative 9. So make sure you can do scientific notation in your calculator. Sometimes these numbers can get fairly large or fairly small. So if we multiply these out, we get 8.47 times 10 to the negative 7. Your turn, number 5. Change 3,280 megameters to terameters. We're starting with mega, going out to tera. So 3, 6. It's in the up direction, so that is negative. Or you can do it by doing 6 minus 12. Gives us negative 6, so that is the exponent on the 10. So we'll take 3280 times 10 to the negative 6. All right, to go to scientific notation, I would do 1 through 3 to the left. If you want to do this by hand, that moves this by 3, so we get 3.28 times 10 to the negative 3rd terameters. Or it could be, you could write it as 0.00328 in regular notation. Example 6. Then do decimeters to picometers. So we're starting here at deci. We need to get up to, or down to pico. All right, so it stops here and then continues down here. All right, so we're going down by 1 here. So 1, 2, but now we're going by 3s. So it's 2, 5, 8, 11. All right, we've just gone down 11, so that's positive 11 for the exponent. Or we could subtract the exponents. In that case, we would do, oops, I think I wrote negative. Yep, positive 11. All right, so if we take negative 1 and subtract negative 12, that's like negative 1 plus 12, which is 11. So two different ways you can get that 11 exponent. All right, now multiplying this, then we get, let's see, 5.6 times 10 to the 7 picometers. Your turn, number 6. Change 0.00482 centiliters to nanoliters. We've got centi and nano. Negative 2 minus negative 9 is negative 2 plus 9, or 7. So 7 should be our multiplier. It's confirmed by counting. So we go down 1 here. Now we're going by 3s, so that'll be 4, 7. So positive 7 on the exponent. By multiplying that out, 4.82 times 10 to the 4th nanoliters. Or you could write it as 48,200. Our next example, we're going to change 45,734 deciliters to megaliters. All right, deci to mega. So we're counting by 1s here, so 1, 2, 3, got 4 up to here. And now we're going by 3, so that's going to be 7 total. We're going up, so it'll be a negative exponent. We'll take that number and multiply by 10 to the negative 7th power. Another way of finding that is negative 1 minus 6, which is negative 7. All right, so multiplying this out, we got 1, 2, 3, 4. So that gives us 4.5734 times negative 3rd megaliters. Your turn, number 7. Change 2,186 centigrams to gigagrams. So starting here at centi, you need to get up to giga. All right, so we're counting up by ones here. 1, 2, 3, 4, 5. Now by threes. 8, 11. We're going up, so it's going to be negative. All right, 10 to the negative 11. Or we can find that by doing negative 2 minus 9, negative 11. All right, now multiplying this out. 2186 times 10 to the negative 11th. We get 2.186 times 10 to the negative 8th. Sorry if you can't read that, negative 8 gigagrams. Now, all these units aren't just for scientific applications. They're cropping up in all sorts of things that are making it into news, could be into products like computers. It's actually pretty common now to see these metric prefixes on marking material for computer parts. So for example, if we're talking about bytes, a byte is the amount of memory it takes to do about 1 character of text in computer memory or in storage. And then we multiply that, we stick these metric prefixes on to talk about, say, 1,000 bytes, kilobyte. You have 1,000,000 bytes, a megabyte, and go on and on. We could be talking about gigabytes and terabytes. And so, size of a small file on a computer might be measured in kilobytes. A web page or an image you download or email might be a couple megabytes. Capacity of RAM for a computer is often measured in gigabytes. And then the storage for a computer is often measured in terabytes. All right, so for your turn, number 8, suppose you've got 2,538,258 megabytes of files. Will they all fit on a 2 terabyte hard drive, or do you need to get a bigger one? All right, so there's the files. Now let's convert these to terabytes. So we've got mega, and you get up to tera. So go up 2, and that is difference of 6. And since we're going up, it's going to be negative, or we can do 6 minus 12. So that gives us an exponent of negative 6. So we're going to do 2,538,258 times 10 to the negative 6 power. That equals 2.538258. So that's how many terabytes we have. It's over 2. Nope, it's not going to fit. Got to get the bigger size. Now another place that these prefixes come up is in medicine. So you may have heard some doctors say, I need 50 cc's of adrenaline. Which I don't know if that's a proper dosage. Might kill somebody with that much. I don't know. I have no idea. But have you ever wondered what a cc is? Well, as it turns out, a cc is a cubic centimeter. It is a cube with 1 centimeter on all the sides. And as it turns out, if you fill 1 cube centimeter up with liquid, that equals exactly 1 milliliter. So CEC is just a milliliter. So really the doctor is ordering 50 milliliters of adrenaline. Your turn, number 9. A patient requires 0.03 liters of medication. How many cc's should be administered? All right, so liter is a base unit. So we're going to start here. We want to get down to cc's, which is milliliters. So we're going to go 1, 2, 3 down. These are all single steps. And we're going down, so that is a positive exponent. So we're going to multiply this by 10 to the third power. All right, multiply by 10 to the third moves the decimal 3 to the right. 1, 2, 3 gives us 38 milliliters. So 38 milliliters of that medication should be administered. All right, the metric system is becoming more and more popular all the time. You're even starting to see products in the United States having their weights or volumes listed in both English units and in metric units. So I recommend becoming very familiar with this. It's commonly used more and more in scientific, business, and in medical applications. So this is an important one. Have a great day, everyone.